So we're going to do a couple examples of the ratio test. So looking at 3a, we have our term, our an term is n plus 1 over 2n all to the power n. Okay, so I'm going to set this up this way. The numerator is going to be our an plus 1, so we're going to end up with n plus 1, so plus 2 over 2 times n plus 1, so it's going to be 2n plus 2, and that's going to be all to the power of n plus 1. Okay, so that's our an plus 1, and then our an is going to be n plus 1 over 2n all over n. Okay, so we should group some of these terms together, things that are similar. So we are going to simplify this expression. So limit as n approaches infinity. So we're going to end up with, and I'll just color code some of this. So we're going to end up with n plus 2 to the power of n plus 1. And because there's one more term, I'm just going to separate that into n plus 2 to the n times n plus 2. So just going to highlight where that came from. That plus 1 is going to generate that extra factor. Okay, and the reason why I'm going to do that is just so that we want factors to cancel out. So it's going to be nice to know if we have the same number of factors. Okay, and then the 2 times n plus 1. Okay, so we're going to get 2 to the n plus 1 times n plus 1 to the power of n plus 1. Okay, so then, and again, I'm just going to maybe bracket that like this, n plus 1, and that just allows me to kind of keep track of some factor terms. Oops, that's not from there. It's going to be from that extra plus 1. Actually, I'm going to do it in yellow because that extra factor here comes from that extra plus 1 as well. Okay, so there's my terms there, and then in the denominator here, I'm going to end up with n plus 1 to the power of n, and in the numerator, I'm going to end up with 2 to the n, and then n to the n. Okay, so we're going to group some of these things together. Let's group these terms here. So we have these terms we're going to group together, and so we're going to end up with a limit as n approaches infinity of 2n over 2n times 2, and that's going to be those terms there. I'm going to group those in green. We can group together, it looks like we have some comparable powers, so I'm going to we might run out of colors here, but do these in blue, these two in blue. Okay, so we're going to group those together, and I'm going to end up with n to the n over n plus 1 to the n. Okay, and then because those are common n powers, we can just put them on the outside as power n like that. And then we have these red terms, which I'll group together. And we can do the same thing. If you notice that they both have power n, I'm talking about these red terms here and here, they have common power of n. So I'm going to write this as n plus 2 over n plus 1. Okay, and that's going to be to the power n. And then lastly, I'm going to have the n plus 2 over n plus 1. Okay, so grouping all this together, we can now evaluate this limit. So when we evaluate this limit from the green, the two ends are gonna cancel out. So we're gonna be left with 1/2. Okay, for the blue ones here, the limit of n over n plus 1 is 1 to the power n. For this one here, we're going to end up with n plus 2 over n plus 1 as n goes to infinity. Again, that's going to be 1 to the power n. And then the last one, 2n plus, that's going to just be 1 as well. And in fact, I probably could have grouped that with the red and just had the exponent as n plus 1. Regardless, though, those are all terms that equal 1. Okay, so we end up with 1/2 times 1 times 1 times 1. So the limit is 1/2. Okay, now this is less than 1. So what does that mean? That conclusion that we can make from this is, if the limit is less than 1, this is a convergent series. Okay, so we know that this series then will converge, and it will converge to a finite sum. Okay, again, we don't know what the sum is, but it's convergent, it's useful to us.